6 miles west of Honolulu sat Pearl Harbor, one of the finest natural anchorages in the Pacific, and in 1908 completely useless to the American Navy. A coral reef blocked the entrance. The harbor floor was too shallow for warships. There was no dry dock within 2,000 miles. Congress appropriated $6,200,000 to fix all of that at once, dredge the reef, blast the floor to depth, and build the repair infrastructure that would make Pearl Harbor the cornerstone of American power in the Pacific. I went through naval construction records, studied congressional documents, and used AI to reconstruct how American workers attempted the seemingly impossible and what happened when the Pacific pushed back. Congress passed the Act of May 13, 1908. The order was crystal clear: make Pearl Harbor capable of taking the Navy's biggest warships. But there was a problem standing in the way. A massive coral reef blocked the harbor entrance. This reef had protected the anchorage for centuries. Now it had to be destroyed. Specialized dredging equipment arrived by ship in pieces. Steam-powered dredges too massive to fit through existing channels were disassembled, shipped, and reassembled on site. Workers operated the machinery in brutal tropical heat, with temperatures regularly exceeding 90 degrees. The humidity was relentless. Coral was broken mechanically through repeated impact and abrasion. Draglines removed the broken pieces. Barges transported the rubble away from the construction zone. This wasn't quick work. The Navy estimated roughly 5 million cubic yards of material would need to be removed, and the channel wasn't deep enough. Modern battleships needed deeper water. Fully loaded warships displaced water equal to their weight. A 32,000-ton battleship required approximately 25 to 30 feet of water. Margin had to be maintained below the keel for safety. The new channel needed to reach the target depth to accommodate naval vessels safely. The solution was ambitious: create a 600-foot wide channel through the reef with a minimum depth of 35 feet. The excavation proceeded in stages. First, a massive channel had to be excavated directly through the coral reef. This required removing thousands of tons of coral. The reef wasn't simple solid rock. It was a living structure centuries old. Breaking apart this ancient structure generated enormous quantities of rubble. Specialized equipment had to transport this rubble, and disposal areas had to be prepared outside the harbor. Steam dredges operated continuously when weather permitted. Work stopped only during maintenance and tropical storms. Workers rotated through shifts, allowing continuous equipment operation. In the tropical Pacific, operational daylight lasted roughly 12 hours. Electric lighting adequate for precision dredging equipment didn't exist. Work followed the sun. The harbor bottom itself required treatment beyond the reef. Coral and bedrock had to be removed to achieve consistent depth. Multiple dredges worked simultaneously. The coordination required was extraordinary. Equipment had to avoid collisions. Material disposal had to be managed. Other operations had to continue. Workers were brought from the mainland and hired locally. Disease was constant. Typhoid fever, dysentery, and dengue spread through the work camps. Workers fell ill regularly. The mortality rates were significant compared to mainland construction. The Navy implemented rotation policies. Workers served 6-month tours before rotating back to the mainland. This created constant training demands. New workers needed to learn equipment operation, understand safety procedures, and adapt to the tropical climate. By December 1911, years of relentless work had transformed the harbor. On December 14th, the armored cruiser USS California entered Pearl Harbor safely. The vessel carried Hawaii's former leadership, Sanford Dole, who had served as president of the Hawaiian Republic, and Queen Liliuokalani, Hawaii's deposed monarch, two figures who represented the opposite sides of the same historical rupture, now aboard the same American warship, sailing into an American military harbor built on what had once been Hawaiian sovereign territory. Hawaiian sovereignty had ended. American military infrastructure was being projected through Hawaiian territory. The impossible task of dredging through coral had become routine. The reef had been defeated. A dry dock is engineering complexity at its extreme. Ships must be positioned in a basin. Water is pumped out. The entire vessel, weighing 32,000 tons or more, sits exposed for repairs. The dock must be absolutely watertight. Structural supports must distribute impossible weights without deflection. Gates must seal perfectly. One flaw means catastrophic collapse. The challenge of constructing a dry dock in a marine tropical environment had never been solved successfully on this scale. Previous dry docks were smaller and built on firmer ground. Pearl Harbor's dry dock had to accommodate the largest battleships in the world. The foundation had to be solid. The walls had to be poured concrete, reinforced with steel bars. The gate system had to operate thousands of times without failure. The pumping system had to remove millions of gallons of water quickly enough to drain the dock without structural compromise. Work on dry dock. Number 1 began September 21st, 1909. Excavation teams dug into the harbor bottom to locate solid foundation material. The initial excavation required removing 48 feet of relatively soft material down to coral bedrock, capable of supporting the structure. Hundreds of workers removed material in stages. Wooden pilings were driven deep into the foundation. Steel reinforcements were positioned to exact specifications measured and verified by engineers. Concrete was poured in stages, with each pour cured completely before the next stage began. The specifications were extraordinary. Concrete had to be mixed to exact proportions. Reinforcing steel had to be positioned to fractions of inches. Measurements were made repeatedly. Engineers walked the site constantly, verifying that specifications were being met. The concrete had to cure properly in tropical humidity. Traditional methods developed in temperate climates didn't work in Hawaii. Experimentation was constant. Underwater inspection was conducted by divers in heavy suits. Air was supplied through hoses. Communication with surface crews occurred through hand signals and rope tugs. Divers inspected foundation work below water level. They verified that pilings were properly seated. They checked that concrete was curing correctly underwater. They identified problems before they became catastrophic. The gates that would allow ships to enter and exit required specialized manufacturing. Metal was machined to precise specifications. Hinges were cast and balanced. Seals were designed to prevent water leakage. Operating machinery was installed to move the massive gates. Nothing like this had been built before. Every component was essentially experimental. By 1911, the dry dock was approaching completion. The structure had been built to specification. The foundation seemed solid. The walls were complete. The gates were being installed. Progress reports were optimistic. Engineers expected the dry dock to be operational within months. Now what unfolded is something no one could have seen coming. On February 17, 1913, underground water pressure caused complete structural failure. The nearly completed dry dock collapsed catastrophically. A structure built over approximately 3 years and 5 months crumbled. The investment was enormous. Years of work, thousands of tons of concrete and steel, hundreds of workers, all destroyed in a single failure. The immediate impact was shattering. The structure that engineers had carefully designed, that workers had painstakingly built, that everyone believed was succeeding, simply gave way. The floor of the dock burst upward. Concrete shattered. Steel reinforcements bent. The failure was sudden and total. Everything that had been built had to be abandoned. And here's what actually happened that you might not know. The failure wasn't simply structural collapse. It was the failure of a design process that hadn't understood the true environmental conditions at Pearl Harbor. The engineers faced a brutal reality. Their calculations were wrong. The foundation design, carefully engineered based on available data, had missed something critical. Multiple water sources existed below the foundation. Cumulative pressure from these sources exceeded what the structure could withstand. Each individual calculation might have been reasonable, but they hadn't accounted for the combined effect of all water pressure acting simultaneously on the foundation floor. What I truly find remarkable about this failure is that they'd made their best estimates based on available information. but the environment itself was more complex than their models predicted. The coral bedrock wasn't uniform. The water sources weren't where they expected them. The pressure dynamics were different from anything they'd encountered before. Work stopped immediately. The site became a disaster investigation. The question was brutal. What had gone wrong? Engineers conducted rigorous analysis of the collapse. They examined the foundation. They studied the failed concrete. They measured water pressure at different depths. The investigation revealed that the foundation design hadn't incorporated adequate drainage systems to manage underground water pressure. The answer wasn't to abandon the dock or reduce specifications. It was to fundamentally redesign how the foundation would be constructed. Better drainage had to be engineered. Stronger supports had to be added. The entire approach had to be reimagined based on what the failure had taught them. Construction proceeded methodically, incorporating revised engineering specifications. Workers who had lived through the collapse returned to rebuild what had failed. New workers arrived continuously. The workforce rotated constantly due to tropical disease and the harsh conditions. The project never stopped being difficult. Workers faced the same tropical heat, the same engineering complexity. The difference was knowledge. Engineers now understood what had failed. They designed specifically to prevent recurrence. The new structure incorporated redundancy. Multiple drainage systems operated independently. Stronger supports helped distributed loads differently. The entire approach to the problem changed because the failure had taught engineers what they didn't know. By 1915, the new dry dock was nearing completion. By 1917, the United States entered World War I, accelerating all construction timelines. Pearl Harbor became strategically critical. Ford Island was purchased in 1917 for joint Army-Navy aviation development. Additional facilities were constructed rapidly. Barracks expanded to house growing personnel. Supply depots grew to store increasing quantities of materials. The facility transformed from a specialized repair yard into an integrated military complex capable of supporting fleet operations. On August 21, 1919, Secretary of the Navy Josephus Daniels formally opened Dry Dock No. 1 at Pearl Harbor. The ceremony was triumphant and emotional. The dry dock that had collapsed 6 years earlier now stood complete and functional. 10 years after construction began, after a catastrophic failure and complete reconstruction, Pearl Harbor finally had its first operational dry dock. While the dry dock struggled and recovered, it is important to note how the other construction process proceeded relentlessly. By 1911, machine shops were operational. Supply houses stored provisions. The Naval Yard continued expanding. The initial 85-acre reservation was expanded significantly over the decade. Land was added systematically as congressional appropriations continued flowing. By 1919, the facility sprawled across more than significant amount of acres of developed and operational naval infrastructure. Machine shops were constructed with the latest equipment available. Precision tools were installed for fabricating replacement parts. Supply depots were built with capacity for thousands of tons of materials, ranging from coal to ammunition to spare parts. Administrative buildings were erected to house command staff. The buildings had to be constructed to withstand tropical weather, salt air corrosion, and periodic hurricanes. Worker housing expanded continuously as employment grew. Barracks for sailors were built in large clusters to accommodate thousands of personnel. Officers' quarters were constructed separately. Workshops for metalworking, carpentry, machinery repair, and electrical work operated around the clock. The construction of these support facilities required as much engineering effort and labor as the dry dock itself. Buildings had to withstand not just normal tropical weather, but the extreme conditions of tropical storm season. Materials had to resist salt corrosion. Roofs had to be designed to shed heavy tropical rains. Water systems had to provide adequate supply for thousands of workers and for ships' needs. Fresh water had to be transported from distant sources and stored in large tanks. Sewage systems had to handle the waste from a growing population, numbering in the thousands. Electrical systems had to power machinery, facilities, workshops, and living quarters continuously. Cable runs had to be protected from salt corrosion. Generators had to operate reliably in tropical humidity. Supply warehouses were constructed with ventilation systems to prevent fungal growth and moisture damage to stored materials. Large storage tanks for oil and fuel were built and positioned for rapid fueling of naval vessels. Some older coal-burning ships remained in service, but oil had become the primary fuel. The variety of construction projects was enormous. Every type of building was required. Every type of infrastructure had to be developed. And what made the facility expansion extraordinary was the construction of support facilities continued simultaneously with the dry dock reconstruction. While the dry dock was being rebuilt after the 1913 collapse, new barracks were rising, new workshops were being constructed, and new supply depots were being built. The facility expanded continuously, even as engineers solved the problems that had caused the dry dock collapse. Ford Island, purchased in 1917, required extensive development separate from but coordinated with the main naval base. Runways were constructed from coral, compacted and treated to create solid surfaces for aircraft operations. Hangars were built for aircraft storage and maintenance. These structures had to be large enough to accommodate aircraft, strong enough to withstand tropical storms, and designed to allow rapid aircraft launch operations. Barracks were erected for aviation personnel. The integration of naval and aviation facilities required unprecedented coordination. Army and Navy units had to work together to develop facilities serving both services while maintaining separate command structures. Employment grew dramatically. By 1919, thousands of workers were employed at Pearl Harbor. Construction continued even as early facilities became operational. The demand for labor was relentless. Workers came from the mainland, from the local Hawaiian population, and from immigrant communities. The workforce was managed continuously, trained constantly, and rotated frequently as tropical disease took workers out of service. By 1919, by which the Pearl Harbor was a complete military facility, though still expanding. Pearl Harbor transformed between 1908 and 1919 through sheer construction effort. Coral reefs were dredged, a dry dock was built, collapsed, and rebuilt. Support facilities were constructed. The work was performed by thousands of workers in brutal tropical conditions. The outcome was a complete military facility capable of supporting the Pacific Fleet. The engineering methods pioneered at Pearl Harbor influenced naval base construction worldwide. The solutions developed for building in tropical marine environments became standards for future projects. The dry dock design, refined through catastrophic failure and successful reconstruction, became a model for other facilities. The workers who arrived by ship, who operated dredges and poured concrete, who rebuilt after the 1913 collapse, left no monuments to themselves. Their names are forgotten. But Pearl Harbor itself stands as proof of their work. Between 1908 and 1919, American workers built one of the most strategically consequential military facilities in history. They couldn't have known what it would one day be called upon to survive. But they built it to last. If you found this story of construction and engineering innovation fascinating, subscribe deep dives into construction processes and let me know what reconstruction you want to see next. See ya.